Hey everyone. In this video I want to make an argument for using decodable NSManagedObjects and compare it with a more common approach. First, let's go through a little demo app I made for this. All there is to it is this screen. You tap Get All to download a list of photo JSON objects, parse them, and save them in a core data store. I put up a list of photo titles here to see that everything works, and that's it. Now, a common approach for this case would be to create a photo struct, make it decodable, and use a JSON decoder to parse an array of these photos. Then for each of these photos, we create a photo managed object and populate its properties with the data from the photo struct. Simple enough, but here are a couple of areas for improvement. For one thing, the struct is basically an intermediate representation and has no reason to exist other than for parsing. Now, since our managed object is generated, integral types are either int 32 or 64, which is a nuisance to work with, and almost all of its properties are optionals regardless of how we define them in our model. So here's what I'd like to suggest. We manually define our managed object and implement decodable ourselves. First, I'd like to point out how this approach addresses my previous concerns. For one thing, we can more accurately define our properties as non-optionals, removing unnecessary forced unwraps from our code, and we can use ints instead of having to work with int64s. And the photo struct that we use just for parsing is now gone as it's no longer necessary. When we want to decode an array of photo managed objects, we first have to pass in a context to the decoder, as it's needed to instantiate managed objects. Once we pass it in, we can decode exactly like we did the structs before. Within the photo managed object itself, we first pull out the context we passed in and call the context initializer. Then we decode each property using the coding keys enum we defined here. And we're pretty much done. If you want to check out the code yourself, I linked it in the description. You can check out the two branches there to compare the two approaches. That's it for this video. If you liked it, then like it for the algorithm, and I'll catch you in the next one.